6 more minutes. So we'll start at 17:10. You can feel free and interact. I won't. Well, we can chat, I guess. I don't know. Are there any concerns before we start? Any random things? Issues, problems?
No problems, yes, sir.
Is anybody listening? What is the problem? Tell us the problem. What's the problem?
Yeah, there's no problem, sir.
Oh, okay. How about the others? Are there any concerns or problems, issues, and are you struggling with any parts of the course or something? We might as well use this 5 minutes instead of me leaving. We can use this 5 minutes to talk about problems. Yeah. I wonder why this thing doesn't always use 720p, which is a bit weird. Yes. And no, Peter, not anything to do with marking. When is the marking? No, that's not a problem, right? I mean, actually, I saw him. He just came up. I mean, serious problems here. By the way, the marking is supposed to be done by tutors, and tutors haven't been appointed yet, which is
Hello,
a
sir.
bit of a delay here. Yes, hello, madam.
Sir, I think my problem, please, you should feel for us. Don't give us another task because we already have a lot of things.
What are you talking about? What do you mean, don't give us another task?
No,
What are you talking about?
just for now, sir. No, I'm just telling you in advance, just in case.
No, but I'm confused. Where is this coming from? What do you mean, don't give us what tasks do you have in mind? What tasks? What task are you talking about?
The quiz.
Well, the quiz is there next week. We have a quiz next week. What are you talking
Next
about?
week, sir. Oh.
Have you not bookmarked the? You see, this is a problem here of not being serious. Have you not bookmarked the calendar? The calendar has all these things you're talking about, yeah?
That's why I can always change.
No, there's nothing like changing. We are already behind here. Have you bothered to look at the syllabus? We're already behind. We are moving at snail's pace actually, right? And the goal, right? The goal is always to finish the entire syllabus. And whether you like it or not, we're going to finish this syllabus. In fact, the only way that we'll not be able to finish the syllabus is if you quit, actually, right?
Okay.
Yeah. So we have to. We are dragging. We were supposed to transition to lecture series number 6 next week, but there's a lab session, which I think, to be fair, should be done within the course of next week. So you at least have hope by this week, everybody will finish off the remaining bit of lecture series number 5. You must consume all the screencasts. You must read all the notes, right? Make sure you go all the way up to licensing. You must read all the complementary resources. Yeah, all those books that Clayton is uploading onto the Moodle. How many of you have bothered to read the GNU manifesto? Yeah, how many? Can I have a show of hands? How many have bothered to do that? Type 1 in the chat if you've read the GNU of the GNU manifesto, however you want to call it. Type 1 in the chat. What are you doing if you're not reading?
Which manifesto is that, sir?
Okay. Well, you go on Moodle, you know exactly what I'm talking about. The GNU manifesto. It was indicated somewhere further down the notes. I guess in the bibliography slide. Let me check here, see if I've uploaded that thing. Maybe I haven't. And what I'm going to do now is I'm just going to share this thing actually.
Because as far as I'm concerned, I've read all the handouts you have uploaded on Moodle. Now about the manifesto, I'm not sure. Maybe I'm
so
not.
It's not just well, it may not have been uploaded onto the Moodle, but it's here. Have you bothered to read this resource number 2? Did you get all the way up to slide number 149? Yeah.
Oh, I got to that slide, but I have not just read that part. I'm yet to research during this week.
So you haven't read anything. There's nothing like researching. It's just reading. You don't have to research anything. You just read. It's already there. I mean, if you want, maybe people want us to kind of like to give them the GNU manifesto, right? Sad, right? Manifesto. What are you doing if you're not reading then, right? What are you doing? What have you been doing these last 2 weeks? Yeah, this is...
We've been solving the assignments we were given, sir.
Oh, okay. That's good. You should do the assignments you've been given, but you're not doing these other assignments that yeah. All right, this is it here. You're not okay. All right, any other concerns besides Miss Memory who was saying, no, sir, don't give us any more tasks. You want to laze around at home whilst in quarantine, right? This is why you don't want to be given more tasks, which is a bit weird here, but...
Sir, you didn't finish explaining why you haven't marked our
I did, I told
quizzes.
you. There are no tutors allocated to the course. The marking is done by tutors normally.
I see.
So that's the
No,
reason there's a bit of a delay.
memory interrupted you, so I didn't get that part.
Oh, sorry. So maybe I think I'm getting older, so I was thinking I respond. I'm sorry if I didn't say that. So that's the reason why there's a bit of a delay, but we'll try and get there. The assessment will be graded, don't worry. I know, I mean, people normally get excited about, results and whatnot, right? Or results, I guess, are important. Suppose, I don't know. Any other concerns besides the concern about the marks and the task?
Sir, you spoke of lab session next week. How
It's
are
not a
we
lab
going to
session.
do that?
It's a tutorial. It's a tutorial that you watch, and I'll talk about it. It's in the briefing that I prepared, so I'll talk about it as well. And I see we're already at 17. So next, if we look here, there's a dog barking in the background. So the person who was asking about the GNU manifesto, GNU manifesto, I've just uploaded it, right? So you'll find it under the resources section of assignment number. So you just move it up here. So you'll find it there. It's there now, seeing as you are unable to find it on your own. Any other comments before I start? Any random things you want to? I guess we'll talk about this at any other business or something. Great. It's about 17:12. So we can start. Right. Okay. I haven't even bothered to check how many people are actually in the house right now, but hopefully there's a reasonable number of people. Let me just quickly check. 26. Oh, we should thank God here that we have more people, right? We must pray on Sunday, all of us. We should go to church and pray, and pray that we have more people attending sessions. Yeah, it's always good. I hope so. Take a screen grab. By the way, have you started learning this other? Are you having classes in these other courses? Your minors, EDU 1020, and these other courses? Yeah.
Yes, sir.
Yes.
Okay. Perfect.
Yes, sir. Yes, sir. Time.
Okay, I'm just sharing my screen. I'm having trouble sharing my screen. Just give me a few minutes, and I'm coming just now. Yeah, so I'm sorry about that. There's usually noise that comes from the neighbors, so I normally have to close the windows. Okay, so short briefing today, guys. Please, again, if you need to interrupt me, if you need clarification as I'm walking you through these things, just feel free and interrupt me, right? Great. I thought we'd just talk about these few things here. Just a summary of the last batch of screencasts that was shared. I guess this is just a reminder of what is in the slides and what is in the what's in the screencasts, right? And then, as always, I'd appreciate it if you guys could give us feedback on the resources that have been shared. So, like, we already had feedback from someone who said the GNU manifesto was not uploaded on Moodle, so he wanted us to upload it for them. We just did. Thank you for the feedback. And then we just have a short Q&A session at the end in case people will be writing down questions as I'm walking us through this. And then I'll give us just a sneak preview of what you'll be able to find in the tutorial exercise, right? We should be available this week. And then we'll have some random chat about random things here. So if you've noticed, the last batch of screencasts, pretty interesting stuff. We talked about a number of things here. Although a huge chunk of what we spoke about, what we discussed was centered around system software, right? So hopefully by now, everybody has a firm understanding of the three broad categories of system software, right? And yes, why Lighton is firmware not there? Well, we said that in certain instances, it could just be lumped onto operating system software because it turns out that it performs more or less the same function, right? So this last bullet point, if you will, was supposed to be something like firmware / operating system software. The only difference is that for the most part, firmware typically sits on write-only memory, right? Typically ROM or something. Although these days, it's common practice to have firmware sitting on so-called EEPROM or PROM, right? So you can literally make changes or update the firmware itself. In the past, machines would typically have would be accompanied by BIOS software that you could not modify, but these days you can update the BIOS software, right? So that's that. And I just remembered here, I should change. I should upload link to BIOS video. There's a BIOS video showcasing. I mentioned in the screencast that I would upload it, but I just realized I didn't upload that. All right. So we looked at utility software tools, right? We know what these are, and if you notice in the slides, right, in those visuals, the images that I have in the slides, and in fact in the screencast, I was trying so very hard to use examples that people are familiar with. So I was making reference to things that you'd find on an Android device, right? So typically on Android, you have a sort of software application that you use to monitor the amount of space that you have. In fact, for most of you, I'm sure you've been alerted on numerous occasions by Android to say you're running out of space or something, right? It turns out that that's a classic example of utility software, right? So we hopefully everybody now knows what utility software is all about. And then also had a broad discussion of so-called language translators. Key selling point for language translators is this whole notion of them translating program notation written in one source notation into a completely different but equivalent notation, right? And we did emphasize the fact that this is usually very helpful when you're wanting to translate something that is written by a programmer into a format that native hardware, computer hardware is going to be able to interpret, right? So moving from high-level language notation onto ones and zeros, right? Machine code. Because the computer cannot execute high-level program notations. As a programmer, you would sit there and you're like, oh, I'm writing Python, I'm like print test, oh, print quiz, is that quiz 4 is next week. See, the computer doesn't understand what this print quiz 4 next week is all about, right? But as a programmer, you know what this is. So what do you do to make it possible for the computer to execute this? You need an interpreter. In this case, because I'm using Python, I would need an interpreter that's going to translate this thing here into a notation that the machine is going to be able to understand, right? And in this case, because Python, the language I'm using here, I'm showcasing here is an interpreted language. In this case, you'd need an interpreter, right? In the case of a compiled language, you'd need a compiler, right? In the case of assembler or assembly language notation, you need an assembler, right? So, but the key selling point here is that you need, people who don't listen, sending in from outside. You typically need a language translator to convert program notation from one form into the other, right? Same thing, but different representations. A really easy to remember way of thinking about what a language translator does is by thinking about what a normal translator does, right? If you have a person, a Chinese person coming from China, and they want to speak to your grandmother or something, you typically need someone who understands Chinese, right? That person who understands Chinese would be the equivalent of a language translator, translating the information that your grandmother is saying into Chinese from maybe Chewa or Bemba to Chinese, right? In certain instances, maybe you might need to translate from Chewa or from Chewa to English, from English to Chinese, right? In which case you need different translators, right? So this is the whole idea behind language translators anyways. And then finally, we looked at, still on the categories, we looked at so-called operating system software. And I guess the thing worth mentioning when it comes to operating system software is that it's really this class of system software that application software uses to interact with the hardware. Remember that a piece of software such as Ocular, which I'm using right now, cannot interact with the hardware directly. It cannot direct the hardware to perform a desired function. It must go through the operating system. So the role of the operating system is essentially to manage resources that are used by various applications, right? Easy to remember things here. And then something else we did was we snuck in something to get an appreciation of how computer software or computer programs are executed. We walked through the life cycle. So what happens when you run a program? Oh, I want to run LibreOffice, I guess. What happens from the point when you go to your piece of software and you click the software, you run it, you click it, and it opens up? What's happening behind the scenes, right? We explained this life cycle. We mentioned that obviously one of the key requirements before you use a computer program is you must download it, right? Get access to it. You download it and then optionally install it if at all it needs to be installed. But in the event that you're running like a portable application, for instance, or a program that doesn't necessarily have to be explicitly installed, all you have to do is you download it. So once you download it, when you run it, what the computer does is when you run it, you're running it from computer storage or from secondary storage on your hard disk, typically, right? Let me just check this and I want to get in. Yeah, I'm serious. The first thing that happens when you open up the program is it's going to be loaded into primary memory, right? So life cycle begins with the program sitting on secondary storage. From secondary storage, once you run that program, it's going to be loaded into primary memory, which is RAM. From RAM, what the CPU is going to do is it's going to get individual instructions associated with the program piece by piece, one at a time, and go and execute it on the CPU. You understand this? And I have nice visuals in the, guys, I'm really, to be honest with you, I'm really proud of my visuals here. I'm trying to showcase my, presentation skills, right? Mentioned here, nice visuals of what's happening behind the scenes here. Right? This is what I'm talking about here, this section here. Right, so a program, right? Here's the thing, you have Chrome. You want to run Chrome. Oh, I want to access Moodle using Chrome. For you to access Moodle using Chrome, you need Chrome, right? Before you can use Chrome, you need to download Chrome and install Chrome on your computer. When you install it, the installation files associated with Chrome will sit on secondary storage on your hard disk. Every time you run Chrome, open it up, Chrome will be loaded into memory, right? Chrome will be loaded into RAM. From RAM, each of the individual instructions will be fetched and executed on the CPU. One instruction at a time. Now, this is some people normally get confused here, but it won't make sense because we have dedicated sessions to look at the so-called machine cycle. A piece of software is made up of instructions, a lot of instructions, thousands of instructions sometimes, right? Every time it's loaded into RAM, the program is not executed as a whole, but rather each of those individual instructions. All that is possible because the CPU oscillates at a very fast rate, right? So those specifications that you have on your machine, let me check mine here. It says, oh wow, it's not here. Let's look it up as an example here. This is a nice example. I have a Lenovo IdeaPad, and I'm ashamed I have an IdeaPad here, 320 specifications. I can just find the processor speed here. I don't know if I'll be able to find it here. CPU. Poof, it's not here. It's a bit weird. Performance. Aha! I don't know if you can see this. Now, I don't know. I just went to the first result that I got, right? You see this metric here that says clock speed? So for a Lenovo IdeaPad, which is what I have right now, whenever you see something like 2.4 gigahertz, what this means is that the CPU is able to process things at a rate that is 2.5 giga is billion, right? So 2.5, 1, 2, 1, 2, 3, 1, 2, 3, right? So in any given second, this number of instructions are executed on the CPU. This is how you're able to use a program like Chrome that has thousands of instructions, right? Why? Because instructions are executed one at a time, but at a very fast rate, right? So hopefully this makes sense. Really nice and interesting things going on here. And then finally, we really went through a brief chat on licensing. We first of all started off our discussion by highlighting the fundamental difference between copyright and license. A lot of people normally get this wrong, right? They confuse copyright and licensing. Typically, copyright will specify who owns the rights to a piece of software in this case. And the licensing, we explicitly state what sort of things you are allowed to do when you gain access to the software. Remember that thing that you normally click next, so I agree to the license, that is the license. Typically at the bottom of the fine print, you find the copyright note, and then they'll tell you copyright Microsoft or something. Microsoft would be the owner, it'll be copyright owner, right? The license is the fine print that you'd be reading. But we're setting the stage to have a very lengthy discussion on the fundamental differences between so-called open source software and commercial versions of software, right? And we went through, a series of examples of open source licenses that are out there, different licensing schemes that are used, right? A combination of variations of all these different things. So free and open source software, freeware, copyleft, right? So these are all hopefully different concepts that everybody now understands, and I know you understand because you're smart, right? Great. This was just a quick rundown, guys. And the feedback was supposed to be after here. I'm just going to pause here and just try and find out if people have questions based on what was in the screencast, right? Guys, how many links are there? I have no idea. I don't know. Are there any questions? Are there any questions? I was just responding to Comfort, telling him that there are probably billions of links here now. Google.com, Google.com. No questions, so everything was clear. You don't need clarification on any aspects of the screencast. Everything was very clear, right? Loud and clear. You want to understand these things because it turns out that some of these concepts, we build upon them when we discuss lecture series number 6, for instance. Out of a group of 30 people, nobody has a question. This is a bit strange.
Sir, I have a question.
Yeah, ask.
In terms of how software is implemented, we said that the first stage is requirement analysis, and then design of high-level software. In the design of high-level software, is that the stage where they set up the stage for writing algorithms, or that is done in the requirement analysis?
No, that would be, I guess that would be part of the design. I mean, it depends on how you're thinking about this. I mean, some people tell you to say it's part of the implementation, right? I guess it will be part of the implementation because the algorithms you're talking about are the actual specifics of how you're going to write code, right? So it will be part of the implementation. You see, when you're building software, it's like when you're building a house, right? You know that when you're building a house, not the way people do it, say, you just go straight and go and pick a bricklayer. The normal thing is when you're building a serious house or a complex building, you first of all hire an architect, right? An architect will draw up plans for you. Those plans would be the design. And then you hire a construction company who will hire people that will start building things, right? That will be the actual implementation. Yeah, so the algorithms would typically fall under the implementation part. Very easy to remember steps. So you collect the requirements because you need to understand exactly what you want to build. You come up with the design because you just don't build something. You need to come up with a plan on where is the kitchen going to be? What are the exact dimensions of the kitchen, right? Those sort of things. So you come up with the design, and then you do the actual implementation, and then you test because you want to confirm that what you have built meets the requirements. After you test, we have that stage that is tagged as being evolution. Why? Because software is constantly maintained, right? It evolves, it goes through a cycle of evolution. And again, I pointed you to these updates that you normally install on your phones and on your computer. And I know most of you only just click, oh, let's install updates, right? Those updates are part of the evolution process, right? Bug fixes, security fixes, right? Patches. It's part of the evolution or the maintenance part of the software. At that stage, you'd have already finished the implementation, but you go through a loop because certain changes might require including additional like source code to the existing software. Great question, thanks. Any other questions? Can you now explain to your mother or your grandmother how software works? Okay.
Yes, sir.
Ah, great, great. That's good. That was the goal, right? Okay. If there are no questions, then I'll quickly transition to the next part of our session. Is that fine? No questions. Nobody wants questions here. So I was curious if people have feedback on the resources themselves. Do you think there's anything missing? Are the screencasts fine? Are the notes fine? The additional literature that's being shared, is that comprehensive enough? We want more resources. And I guess this question goes to the likes of Ms. Piri here, right? Who's saying, no tasks, more tasks and whatnot. Do you want more? People are not responding. I don't know if they're hungry or something. Okay, if there are no questions, we're just going to keep this short then. People don't want to ask questions. There's something I'm going to make when people are not asking questions is that things are clear, right? Things are clear and everybody understands. Yes.
On application software, I still think we still need maybe another screencast on it, in my case, because there are some things I miss when I'm watching the screencast.
Yeah, so this is the whole point of having a quiz session. This is the whole point we have the mailing list, right? What purpose is another screencast going to serve? When in fact the things I'm going to talk about in this other screencast you're asking for are going to be exactly the same things I talk about in the screencast.
Right.
No, it's fine. I mean, I'm just trying to probe it, try and better understand exactly what part of the screencast is unclear. Which part of application software is unclear? Is there a particular category of application software that wasn't clear?
Maybe I should just check it out again, but for now, I'll wait until you're done.
No, but we are done with this series, lecture series. We are done.
Okay.
Am I putting you on the spot here?
No, you can continue, sir.
No. I mean, I'm trying to. You see, there's a reason why I'm probing further. I'm trying to. It might just turn out. It's usually the case that if somebody has a concern, then it's likely that a number of people have a similar issue. And so what I'm trying to do is try and figure out exactly how we can fix this, right? Can you do you remember any part of application software that was a bit iffy, that wasn't very clear for you?
I'll email you. I have to go through because
Okay.
I've been checking from one assignment to another now, switching from screencast and studies and different things.
Okay, I see. I saw the class rep just now. She was pitch black somewhere. Is it? Are we living in different parts of the country? It's not yet. I know we are experiencing. Is it short days and long nights or some crazy stuff like that? But it's still daylight here. Any concerns? Does anybody share sentiments from Leandro with regards to application software? If you don't ask, right? If you don't ask, the questions will be asked on your behalf in the quiz next week. So if I were you, I would ask these questions either now or via the mailing list. Yeah.
Sir, how does the operating system work?
What do you mean? How does it work?
In terms of installing, in terms of memory allocation?
Yeah. So it turns out that yeah, this is the thing. It turns out that there are certain concepts that we didn't really we don't cover in this course. So there are scheduling techniques, for instance, that are taken advantage of, and we didn't really talk about that. If you want, that's not really, it's beyond the scope of the course, but if you're interested in that, I will share literature, right? I won't upload it on the Moodle list, it's confusing to people, but I'll share some resources that you can probably go through. I mean, you come across things like the different modes that the operating system operates in, so kernel mode and user mode, for instance. Scheduling techniques that are used, right? And then you'll be able to better understand exactly how the resource allocation part works. But for now, we are abstracting all those gory details by just saying the major role, one of the major role of the operating system is resource allocation, right? For us, for the purposes of what we're doing, that should be sufficient, really. Yeah, but typically there are scheduling techniques that are used, right? So you see, your CPU, right? Your CPU typically execute, I said that it executes a number of instructions at any given point in time, but it's one instruction at a time. So you have to think about this, right? Say, but how exactly how does the operating system, because the operating system is the one that's fetching the instructions from main memory, right? Taking it to the CPU. Question to ask is, what decision does the operating system, what sort of decisions does it decide on which instruction it has to fetch, right? Those are things that we kind of left out, right? There are techniques behind the scenes, time sharing techniques that I use, so, but it's beyond the scope of the course here. But if you're interested, and I do encourage you to read up on this, the thing that's on Moodle, right? This thing that's on Moodle has those answers. And I'm guessing the people that have read this probably came across this. So this resource here, you want to read this as well. Not history of operating systems, I'm sorry. What the hell? This, so introduction to operating systems, right? I'm a bit trying to be very careful here not to include a choice of what to include and what not to include, right? So, but anyway, so the simple answer to your question is there are scheduling techniques that I use, right? And then it makes intelligence decisions on how best to allocate memory to the different applications. And by resources here, where I did mention that we're making reference to things like memory and CPU time, for instance, right? So if you notice here, an example of how this resource allocation might work is if you look at my tabs here, I have a number of tabs, right? But the operating system knows that out of these different applications I'm running, there are certain applications that have been dormant for a prolonged period of time. So it will not prioritize those particular applications. It will give preference to, in this case, Chrome, because it's the application that I'm currently running right now. And I'm actually context switching between Chrome and Ocular, right? So it will prioritize these different applications. At the point when I swap out and access LibreOffice, then it will realize, so this guy wants to start running LibreOffice, right? And then it will probably increase the priority level associated with LibreOffice, right, in this case. I hope that kind of like answers your question here. Great questions nonetheless. Any other questions?
So in terms of when you explained about how software is designed for a specific operating system and computer architecture, then what makes a specific architecture unique from another? Because we already said that hardware is directed by software. But again, we also discover later that hardware accepts a specific type of software that is designed for it. Then what makes a specific architecture unique from another so that it decides that, okay, this software I can process this type of software and I cannot process that other type of software. Then what makes different architectures unique from the others, and is there an advantage there? Maybe.
Well, so what makes it unique is the actual hardware design decisions associated with a piece of hardware you're running, right? And by architecture, actually, what we placed emphasis on was we raised this whole notion of, oh, you have 32-bit and 64-bit architectures, for instance, right? Of course, there's more, but we sort of like focused on those two aspects because it turns out that we have a separate discussion about that. But fundamental, actually, what makes these different architectures different is dependent on the key function of the piece of hardware. So typically, server computer systems would typically make use of 64-bit architectures. It used to be the case historically that your typical laptop or desktop-based computers would be based on 32-bit architectures. But these days, I think they're slowly being phased out, and most of these hardwares that are being manufactured are actually 64-bit architectures, right? So what sets them apart really is the function, the key function that that piece of hardware is going to function. If you buy a laptop, you know that it's going to be used for a generic purpose, right? You rarely use it to process or to run applications that require massive processing power. So design decisions associated with the sort of hardware implementing are going to take that particular aspect into account. So the decisions really will be tied to what that piece of hardware is going to be used for. And this actually raises interesting things associated with these other operating system softwares like Unix-like operating system software, right? What you immediately realize is, so these things like Ubuntu, for instance, Linux-like operating systems are designed to be accessed by multiple users at any given point in time. That's not the case for your average Windows-based operating system like Windows 10, for instance, right? Because the assumption they're making there is that the person who's going to install this piece of operating system software is likely going to be the only person logged on at that point in time when they're using the computer, right? If somebody else wants to use the computer, the other user has to log out before the other one can log in. Right, so again, it all boils down to what this piece of hardware is going to be used for, right? So that's what sets them apart. I don't know if that helps with
yes, at least I understand. So, in another way, what makes a hardware that runs Mac softwares? What makes them unique? Not me to run those softwares. Maybe on my KDE distro for Ubuntu. Why is it that I can't run those softwares related to the Mac operating system, but I can run them on my Ubuntu? What's the difference in the hardware? Or is it in the case of compilers, they use different compilers or different languages, or what?
No, so it's everything is linked to what's called the instruction set architecture, right? So as a programmer, the thing that you fundamentally use to interact with the hardware is the instruction set architecture. Now, the people that will come up with this thing we're calling the instruction set architecture, and pause, by the way, all this will make sense. We have a discussion on the instruction set architecture, right? But the people that would develop this thing we are calling the software layer, the thing we are calling the instruction set architecture, will make sure that those instructions directly mirror the hardware that they're implemented for. So a Mac computer, for instance, is built completely differently from a Lenovo, right? Well, for the most part, I guess, but maybe maybe the instruction set architecture might be somewhat similar. But fundamentally, it's instruction set architecture anyway. So the interface that you use to interact with the hardware is what sets them apart.
Thank you.
This is an interesting question. I want all of us to understand this. Can you, if this is not clear, can you rephrase your question? This is an interesting question. In case I didn't answer your question, do you want to rephrase that?
As in, I was saying, okay, just in simple terms, why can't I run maybe the Chrome browser that is designed for Mac? It's the same Chrome browser, but I can't run it on Windows unless I download the Windows version Chrome browser, or I cannot run it on my Linux operating system unless I download the Debian-based software for that one. For me,
oh yeah, but that's simple. That's because the version, the Chrome version that you're talking about, is designed specifically to run on a Mac-centric OS.
Meaning
the reason why, sorry?
Meaning the hardware will
no, but so that conversation, no. That conversation has nothing to, at this stage, it has nothing to do with the hardware. In fact, in certain instances, right, if you look up, so when you're looking for a computer to purchase, you notice that, if I can go back to the previous thing I was on, what you'll notice, right, is that, for certain components, like the processors, for instance, now I've never used a Mac, whether it's a Lenovo, and I think I also have an HP, whether it's a Lenovo, an HP, it's likely that you'd be using the same type of processor, right? What that means is that the instruction set architecture associated with those different name brands is the same. If it's the same, then a Windows operating system that I can install on an HP can be installed on a Lenovo. In fact, I dare you. Did you know that? Here's an interesting thing, Patrick, right? And everybody else. It turns out that when you buy that Mac, you can overwrite that Mac and install Ubuntu if you want to. Nobody stops you from doing that. You can do that. You know that, right? At which point you can then run a Chrome version that can that is able to work with Ubuntu operating system. Now, I haven't checked this, but I would like to think that you can install Windows on a Mac machine as well, right? Let me just say, can you install Windows? This is interesting, Windows on Mac. I've never done, I don't use a Mac myself, so I've never done this before, so I wouldn't know, right? Yeah, so it turns out that you can install Windows on Mac. So you can do this because it turns out that typically it's because the instruction set architecture associated with these different hardware name brands is the same. And they're usually the same because the primary indicator, or the thing that dictates what sort of instruction architecture you're going to adopt, is this thing here, the thing that runs the instructions, the processor, the so-called brain of the computer, right? So I hope that helps answer your question. I don't know if this makes sense now.
It makes sense. I think I was mixing them up with the hardware and the software. Now I get the
Yeah,
the software will be controlled only by the OS system. That's all.
Sir, one more thing. We tried running the Ubuntu software on Patrick's PC. Then Ubuntu 18.4. Then when running it on my PC, there are certain functions that run on his that didn't on mine. So
no, that's not true. Which functions?
There are certain command prompts that we tried to set in.
Such as, it's probably just something wrong. Maybe you did go through this. You probably did not go through the right order of installations. You probably did something wrong at some point when you're installing it on your machine. You see, when you successfully install a particular piece of software, it doesn't matter whether you're running it on a Lenovo, on an HP, on a Dell, it works.
Also, the error installation instead.
Yeah, likely. And incidentally, for everybody who is in the house right now, The next part of the discussion is centered around the lab. The lab will involve, in part, us installing two different types of operating system software. So we shall install Ubuntu 20.04, and then we shall install, is it Foco? So I've forgotten the code name for Ubuntu 20.04. But we'll also install so-called Android x86, so a port of Android that you can run on a computer like this. So there's some people out there that came together and decided to port Android. Typically, Android is designed to run on this sort of hardware, right? If you check the sort of processor that is associated with this type of hardware, a typical smartphone, right, is different from that associated with a laptop or a desktop, right? So you cannot easily install, you can't download Android and say, I'm going to directly install it on a Lenovo machine. It's not possible. But there are workarounds. So there are people that have come up with a separate fork of Android called Android x86, which you can install on a computer like this. So we're going to work through that example. It's very easy, I assure you. I know, I have faith, everybody in here is going to do that. And it's quite fun, actually. I assure you it's going to be really fun. So anyway, to answer your question, Leandro, the issue was just maybe the installation process, something went wrong somewhere. And I have no idea what you could have done wrong. You'd have to troubleshoot. The easiest thing to do is to restart the whole process. So reinstall the complete operating system. And in fact, why are you working with 18.0.4? You should go for the latest one, right? 20.0.4.
When I checked on the website, it still showed the 20. The next one was going to be out by June. I'm not sure whether it's out yet.
No, that's not true. Okay, maybe
it's out already.
Yeah, we're talking about
what is
20.10.
Oh, by then the long standard, the LTS version was 18.04, but now the 20.04 is out. So for him, he just have to upgrade. And I think the issue was with the Wi-Fi drivers. The Wi-Fi drivers were not compatible after installing it on his machine. That's the issue.
Yeah, I mean that's a completely different issue. Now the thing is, some operating systems are notorious for that. So Wi-Fi drivers, for instance, and a lot of people struggle with this, right? I'm surprised though. I was meant to believe that in more recent versions of Ubuntu is not an issue. But depending on the type of hardware you're using, it might just be the case that you need to explicitly download drivers for Wi-Fi, for instance, for Wi-Fi to be able to work, and not just Wi-Fi and Bluetooth as well, right? But for some hardware platforms of some name brands like mine, I don't have to bother installing any hardware, any device drivers rather. Everything just works out of the box. Whenever I install a new distribution for Ubuntu, it works out of the box, right? So, and by the way, these things we are calling device drivers. Here's a quick question for you. Think about this is homework. What type of software is it, right? These are things to think about here. Are there any other questions though? That would be a nice question for a quiz or a test, right? Yes.
For the applications that run on Mac, is it possible to use an emulator to run it on Windows?
Yes. This is what we're doing in the lab, by the way. So in the lab, right, we will be working with what's called a hypervisor, right? And traditionally we've used Oracle VMware for that, right? So if you notice, my hypervisor has two virtual machines installed. I have Ubuntu 20.04. I have Android x86. I could just as well have just downloaded Mac OS. I don't know which OS is the most recent now. I don't follow that. Nobody uses that. Well, I don't. So I could have easily have done this, right? All I'd have to do is download the ISO image for the operating system and then create a new virtual environment and then install Mac, right? I don't know if there's, I don't know what version, is it Solaris or something? Just check here. Or is it Solaris? I don't know which fork it's associated with. Probably not possible, I don't know. Oh, Mac OS, there we go. So all I would need is an OS, Mac OS, and then I'll choose the type of Mac OS that I would need. And then I would be able to run that Mac OS and play around with it right in here. Now, this VMware piece of software I'm talking about is a classic example of what you're describing, an emulator, right? It emulates the computer hardware. In fact, when you go through the lab exercise in part allows you to configure this virtual environment. So you're configuring things like, or the hard disk, for instance, and you're configuring it, you're defining it using software because it's a virtual environment. You configure the CPU configurations, right? The amount of RAM that you want to allocate to that virtual machine. So the simple answer is yes, you can do that.
Okay, thank you, sir.
Yeah. Any other questions? We move on. We must move on in life, right? There are better things to do, like watch more TV or watch more YouTube or whatever, I don't know. Now, guys, oh, sorry about that. Just one more thing here before we part ways. So this is about the lab, right? So the plan with the lab is, under normal circumstances, if we had like face-to-face interactions, you'd have 2 sessions for this, and there'll be a tutor walking around and helping you do things. But alas, there's no tutor, and so the replacement tutor is like the screencast. There's a screencast that helps walk you through what you need to do. All you have to do is just follow through with the steps, and then the Windows part is something that you have to do on your own. So the walkthroughs are centered around, there's a screencast associated with Ubuntu, another screencast associated with Android x86. What you'd have to work through on your own is Windows, and I do encourage you to work towards this. Please do this, right? It will help you understand a number of these things that might be a bit hazy right now. And this applies to those of you that are sitting there and thinking, most of this is not making sense, right? Most of this will make sense if you work through, if you read the literature provided, the complementary materials, the supplementary materials, and if you work through the labs. So you have the entire next week to work through the lab. Very few questions. We're thinking of adding more. Like for instance, I think there were plans to add an aspect of the Android debug bridge, which we haven't included, but we will probably include it. Maybe we will, seeing as we have a week to do this. But if I can open the, if I can open the lab, just a second, guys. So the lab has just a few questions here, right? 1, 2, 3, 4, 5, just 6 questions, right? The first part is pretty trivial, right? I didn't even bother to do a screencast because I think you can easily follow through with the instructions. But you see, there's a method to the madness here, right? Question 1 is really centered around you playing around with so-called web-based applications. In this case, it's cloud-based services, right? The G Suite applications, right? To just work through these instructions that are given in here. If you have trouble, just send mail and then we'll respond. And then part 2, though, will require you to install this hypervisor called Oracle VirtualBox, right? The screencast has directions for what you need to do, where you need to download the piece of software, how you need to install it, how you need to configure it, and how you get to install a guest operating system within this hypervisor, right? So that's question number 2. Question number 3 involves you going through a process of installing, and this is supposed to be Ubuntu 20.04 within the virtual machine that you'd have created in VirtualBox, right? Again, the screencast has details, but there are also steps that you have to follow. But the fundamental thing to do here is we want to use Ubuntu to try and see if we can play around with utility tools in Ubuntu. And then finally, in question number 6, to try and see if we can draw comparisons between desktop-based applications that are running on Ubuntu with cloud-based applications in question number 1, right? So please go through these things, very important, right? Very easy to follow things, very easy to follow through questions, and you shouldn't have trouble, I think. So the details of the screencast will be shared with you, I think, once we part ways right now. I think they're hidden right now, but you'll find them on Moodle somewhere here.
Sir?
Under the lab. Yes?
Just how big is Ubuntu?
20.0.4 is 2.5 GB.
So now for some of us who are not in school again, so that may prove an issue, but I can try to get it.
Okay, listen, if you have, if you have trouble getting it, you can try and replicate the examples and just use Windows instead of Ubuntu. I would like to think most people have access to a Windows ISO, right? Because if you have a Windows operating system running on your machine, then you should have Windows. Now that Windows doesn't have an ISO, it can be on disk or something, right? So if you have trouble with that, I apologize, sorry for that. I mean, you'd have to, sad, right? You'd have to just work with Windows. I guess we can just say this is optional.
But it's a must that I need to get to Ubuntu, sir. Is it a
No, no, this is what I'm saying. I'm saying we just said it's going to be optional, and I guess I'll have to change this. I neglected to think about that. I'll rephrase this tutorial question so that we explicitly state that the part to do with the Ubuntu maybe is optional because it's quite large actually, extremely large. In fact, even Android x86. Now, if I can show you the sizes of the files I'm talking about here, you'll notice that they're quite large, right? So if you can see, Android is 2.6 GB, and then, sorry, Ubuntu is 2.6 GB, and then the Android x86 ISO is 730 megabytes. This generally works quite well on campus because you have access to AD-ROM, and so you'll be downloading these via AD-ROM, but that's fine. We'll tag them as being optional. We'll try and see then if we can just include Android debug bridge. But you can still work towards one, I guess. And then we can draw comparisons. I'll rephrase this. We'll work towards one. These others will be optional, like 2, like 3, for instance. But you want to install LibreOffice in Windows, right? So it will be rephrase this so that you install LibreOffice in Windows and then try and compare LibreOffice with Google Docs or something.
Okay, sir.
The woes of COVID-19, right?
Sir, on the part of installing the operating system, like on my, I'm already dual booting Windows and KD based on Ubuntu. Now, with the issue of installing the VirtualBox, okay, is it possible if I not just install it, since I already have the system, I'm dual booting it on my hardware, is it okay since I will be just testing out the utility software?
Yeah, sure, that's fine. But you won't be able to take this other piece of software for a run, right? Because otherwise you'd have to dual boot this as well. So you have three different operating systems that you're dual booting into.
That's okay for me.
Yeah, sure. If you don't want it, it's fine. I mean, the whole point of doing this actually is we're trying to gain an appreciation of operating system software. And by the way, one of the reasons why this is mentioned in the screencast, one of the reasons why we use Ubuntu as a case is because going forward, once we discuss these other topics, we normally make reference to Ubuntu, right? So we prefer to introduce you to the very basics of how Ubuntu works early on, so that once we start discussing those things, you're already familiar with what we're talking about. Right, so it turns out this thing will come back, but any other questions? But the other reason why you want to make sure that you play around with these hypervisors as well is you see it turns out that there are certain features associated with hypervisors that will help you understand some of these things we're talking about, right? So just reading about these things, reading the notes will not help you. But as you are actually experimenting with these things, working through the labs are there for a reason, by the way. You can skip them if you want to. It's like a lecture, right? You can skip a lecture if you want to. Nobody takes lecture attendance for ICT 1110. In fact, there are people that have been known to skip classes the entire semester and they just write the exam. But of course, the end result is almost always disastrous, right? So there's a reason why the labs are carved out the way they are, because it turns out that they help you understand the things that are being discussed for that particular lecture series and the things that are going to be discussed in the future. So, but of course, because there are no marks associated to this, nobody's going to track whether you are working through these labs, by the way. There's nobody who's going to waste time doing that. So it's up to you, but it's recommended. It's not prescribed, it's recommended. It's a recommendation, right? It's like exercise, right? Recommendation is you must exercise if you want to lead a healthy lifestyle. Nobody forces you, right? But eating is a recommendation, otherwise you die, right? So I hope that answers your question. Any other questions, guys, before we part ways here? Okay, if there are no questions, then I'm just going to transition to the last slide that I had prepared here. Just on any other business, I thought I would just remind us that for those of you that haven't bookmarked the calendar, right? To remind us that we have a quiz next week on Friday, so brace yourselves. And the quiz is going to be on everything we've covered in computer software. So application software down to licensing, right? So it's essentially what we're saying is it's going to be based on these 151 slides, whatever that means, right? So you want to make sure that you prepare beforehand, and who knows, maybe the lab will help you understand some of the things, right? So make sure you prepare, you read up, and then you also work through whatever you can in the tutorials as well, or the lab exercise. What else? What else? Right, I don't know if there are any other random questions that you want to ask before we part ways. Hopefully this interaction was helpful in reminding us what we covered in lecture series number 5. After next week, we transition into lecture series number 6. Are there any questions before I hang up?
Just a simple complaint, sir. From the last quiz we had, your questions weren't clear enough for someone like me who went.
Okay, pause for you. Thanks for that. Okay,
Yeah.
Which question, for instance, was not clear? You can go there. Which question was not clear?
I can't really remember, but yeah, some questions were
something tells me
confusing.
Which part was? Here's a quick question. Now, I don't know if Simtenda is on a retreat or something. It's like he's in the mountains of Tibet. He's become a monk with the hood or something. Looks like he's in the bush. I hope you're okay there. It's fine, and there's Wi-Fi. Normally, monks will be in a secluded place where there is no internet access, right? You look like a monk, Mr. Simawe here. Does anybody share the sentiments raised by Peter here with regards to the questions not being clear?
Yes, sir. It felt as if you were answering the same question over and over and over again. In my case, that's for me.
Yeah, but if it felt like you were answering the same question over and over again, that's different from what Peter is saying. Peter seems to suggest that he had trouble trying to understand what the questions were all about, right?
No, what Leander says falls under my question as well, under my complaint, because I've answered a certain question and then I find a question that is similar to it, so I'm having trouble trying to understand whether you're asking the same question or not.
Like which question, for instance? I can open this up. I mean, I'm trying to not use up a lot of your Jesus Christ. Like which question, for instance? Explain how application software provides a high level of abstraction. Briefly outline how abstraction is used during the design of computer systems. List 2 advantages of abstraction during the design of computer systems. And then briefly outline the role of abstraction during the implementation of computer programs. List 2 advantages of abstraction during the implementation of computer programs. Which parts are these 2 disadvantages of abstraction during the implementation of computer programs? Which parts seem like you're answering the same thing over and over again? It turns out that these were like questions that were associated with trying to see if you understand the different scenarios within which abstraction is being used. The first one was centered around, and forget the thing, I think the issues are to do with 2 all the way up to 6. The first one is associated with the design of computer systems, so we're talking about hardware. The second part is to do with program code, right? Programs, computer software programs. Just the responses that you provide will be completely different, right? In as much as you're talking about similar things, in this case, it's this whole notion of abstraction, but the responses that you provide are going to be different. I have a feeling, what's your minor, Peter?
My minor is mathematics.
Could someone, in the chat, could someone just unmute the microphone if you're doing English and just say hi? Who's doing English? Languages, English.
Waiting for.
Who is that? Paul, are you doing English?
No. No, sir.
Is there
Simawe.
anyone? Oh, Simawe, are you doing languages?
Yes,
Okay,
sir.
great. So Peter, I would encourage you to become friends with Simawe. And this is not and I'm being serious here. This is not I'm being honest here. I'm not trying to kind of pick on you here, but I'm genuinely being serious here. What I've noticed, right? What we've noticed in the past is people, and it's not just this course, people tend to have trouble with how questions are phrased at this level. And it normally takes time, but by the time we're getting midway through the course, you should be able to get used to this, right? So in some instances, you'll be tested based on your understanding, not factual details, right? So usually questions that are centered around trying to assess whether you understand something, whether you're able to critique something, will require some sort of basic, I guess, knowledge when it comes to the language being used, right, which is English here. But I don't know. But you want to talk to Simawe? I'm sure Simawe didn't. Simawe, did you have trouble understanding the questions?
A bit.
Okay, then you're not studying languages, right? Okay. Yeah,
This is when we just started learning it seriously.
Okay. Yeah, but yeah. So I don't know if we can do anything about the phrasing of the questions here. But yeah, something else you want to pay particular attention to, especially as we are writing these more important assessments like the tests, is you want to carefully read the question and understand what the question is asking of you. And I know the temptation is always there. When you see abstraction, then you think you already know the answer, right? You see advantages and abstraction, you already know the answer. But it turns out that maybe the question might be phrased to elicit something completely different to what you're assuming. Always important to read the question over and over again so that you understand what is being expected of you. Are there any other concerns, guys, before we part ways?
And sir, looking at the notes, do you mind increasing the time of the quiz depending on how many slides it has?
No. What do you mean increasing the time of the quiz?
Like for abstraction, I think I'm not the only one who didn't finish writing it.
Yeah, this is, I don't know what you are doing here. I think a lot of people actually finished writing abstraction, by the way. And I checked this, we normally check the logs here, but I won't check them right now. You're probably, there were some characters that they finished writing way before the time, actually. So you see, time is tied to the complexity of the question and the number of questions, right? And if you look at the number of questions that we're writing, come on, let's be honest for once here. Do you mean to tell me, is everybody in the chat right now suggesting that 20 minutes was not enough to answer the previous quiz?
Sir, when you look at writing using a pen and writing using a keyboard, those are two different things. So not everyone is gifted with quick fingers. So people like me.
Not like being gifted. It's a simple. Here's a question for you, Peter. Don't unmute your microphone, right? Which is faster? Yes. When you're writing, you use what? I don't know how you write. I don't write a lot myself. But which is faster? 2 hands or 1 hand?
No. That's different. That's really different. Multitasking is hard.
What is faster? Writing. Which person is going to be more effective? A person who is using 2 hands, right, or 5 fingers when you're typing, or a person who is using just 1 hand? Right?
Yeah, that's the thing. You write with all your fingers, all your 10 fingers. Not everyone uses that. Some people use 2 fingers on a keyboard, and that's a factor, I know. So that's one thing you can put into consideration.
Yeah, no, let's not claim that that's a fact, because have you conducted a study as part of ICT 11 to find out from your colleagues if
No, no,
that's a fact? Maybe
no,
it's just you, right?
no. That's a fact.
No,
No,
fact
I
says
write
no,
using
it's fact, though.
I
It's
write
a
using all
subjective
10
view, it's an
fingers.
opinion. Sorry?
I type using all 10 fingers personally, and I find it a little bit hard. But I know for a fact not everyone uses 10 fingers, because not everyone has invested their time into learning how to use all fingers, as as opposed to using 2 fingers.
And another thing, network. Network. It's in my case, some of the pages take time to load.
That's true. But
mean,
okay.
I feel the same way, because I remember once I was writing a quiz. I actually, what happened? I tried to submit an answer, but it couldn't go through because I got disconnected. Then the network cut, and then now the timer still goes forward. It's not like it changes, so it's sort of a challenge.
Okay, fair enough. I mean, it seems like it's can I ask in the chat, right? Can I ask that if you're experiencing network challenges, beginning now, if you are experiencing, if you are experiencing network issues where you are at, please type 1 in the chat, right? Can you just type 1 if you're, and don't lie, because I know people, right? No, characters are lying. You're in cahoots now, I know you. Francis, you're lying. Okay, fine. So, okay, the network issue, if it's an issue, we'll try and see if we can increase the amount of time then. We'll try and we understand. I mean, if it turns out that it's a bit of an issue, then we'll increase the time. Are there any other issues besides time and typing with 2 fingers and being slow? Are there any other concerns or something? Okay, do you have any other issues that you think I can help you with? Something that you suspect maybe I can help with, maybe it has nothing to do with 1110 or something. How are you managing? Is this stressful, this whole online thing? Is this too stressful for you or something?
Yes. I have to say yes on that one, sir.
It's very, very stressful, sir.
Sir, kindly write
Yes,
more
100%.
Sir.
because of the network thing.
Okay.
And for some reason, I don't know why all the lecturers who went active these previous months have decided to give us work.
Like on Ubuntu.
Well, the issue of lecturers being active, that's a sign, by the way, that this thing is serious. So if you are one of those people who's just decided to think, this thing won't work, I'm sure we'll start face-to-face sessions soon, I'm sorry to have to tell you that you'll be in for a surprise. Before you know it, right, you'll be told that there are exams. And you know what the end result is going to be? You will fail. You will repeat this. You come back in first year, next year. And so if I were you, the piece of advice I have is take this very seriously, right? And if anything is to go by way of example of how serious this whole thing is the issue that Shimao just raised, the fact that lecturers suddenly became active now. It seems like it becomes serious, right?
There is no power. It'll be my light, sir.
Sorry, there's no power.
Yes,
Charge
sir.
your device. Charge your device, and then
There's no
also
source of power here yet, sir. So it's not it back.
invest in
Yes.
these things. These are not expensive these days.
And
Power bank, right? I equally find myself in a situation where there's no power, and when I charge this, I don't care if there's no power the whole day, right? I would still be functional. I'd still be able to do work, right? So these are things to think about, and even more so for people such as yourselves, right? People that are doing an ICT-centric program. You should be at the forefront when it comes to adopting some of these, technologies and hardware, right? Should be on top of the game here. Yeah. Figure out ways of find a workaround for downloading 2.5 megabytes of that iOS. I'm surprised that none of you characters have just said, Lighton, can you just maybe find a way of uploading that 2.5 GB ISO on Moodle so that I download it for free on MTN? You're not telling me that, right? Aren't you thinking that?
Wait, is that possible?
No, but you should be thinking, right? But you're not thinking, are you? Sorry?
Is that possible?
We would think about that.
What do you mean it's not possible? If MTN has directed traffic to Moodle, all we'd have to do is just dump some ISO file on Moodle. Of course, I'll just have to speak to ICT and ask them to say, can you briefly increase the limit of the file to maybe 3 GB so that I allow my students to download this important piece of software for free on the MTN network? And then you'd be able to download it without worrying about data. But you're not thinking, are you? You're not
Yeah,
thinking.
if it's please do it.
Yeah, but you should be thinking about these solutions, right? You should be thinking about which MTN plan allows me to spend maybe 2 kwacha to buy 2 GB for a day, if it's possible. And then I'll buy that using 2 kwacha and then just download as much as I can within that one day. But you're not, right?
But if it's compressed, if you try to compress the same program,
no, actually we have a dedicated session on compression. It turns out that the ISO itself is already compressed. So compressing a compressed file yields very little. It yields very little. So there's very little improvement on the relative size of the file. So if I was to zip the ISO image,
there are no limitations.
I'll try, but
there are no limitations in functionality.
Sorry?
Like when you compress the compressed file, there are no limitations in the functionality.
No. Yes, sir, he's right.
No,
usually
no. We have, by the way, we have a separate discussion on compression, right? Once we start looking at data encoding, for instance, you soon realize that there's so-called lossy compression and lossless compression. Typically, utility software programs like WinZip, for instance, or gzip, right? Gzip would typically make use of so-called lossless compression. So when you compress the file, you're preserving the data bits associated with the data. So there's nothing. All you have to do is install a piece of software that is able to decode that information or uncompress it, and then that's fine. Okay, so people, see you when you see me, which is after next week, I think, for this sort of interaction. But of course, I'll be in touch via email to send through details about the laboratory session. Good luck preparing for quiz number 4. Thank you. See you.
Yes, sir.
Bye.
Yes, sir.
Bye. Hey, guys, it's a thing here, EDU 1020. You guys just have meetings randomly because no email, no nothing. I just discovered there was a class today.
You was checking them up IDU 1020. I'm a posting on there.
Yeah, I'm a Peter saying, is that? School to my physics online the whole time. I'm a Peter saying, I'm a double class is there.
Yeah.
Inaweza kutumira wewe sonzo yangu.
Yeah, unakuwa na yona after udara na nienda pa class 14 hours nikachekinga sana. Ndio after udara sana. Then yesterday also I checked today after udara.
Manja paja, that was during the same lecture. So I just checked you the list and so you're not. So it's not stuck to me that way. So in the show full of points at way. So
guys, the lab is going to be uploaded on Moodle.
Yeah, Koneka so
he will tell us. He will tell us.
Yeah. So wait, okay. Guys, when is the next meeting for you?
I think Friday.
Mzanne committee anoza.
Friday.
Inganyama lab ile bwanje kandawe nyani pita mwezi.
Azatiuza mpondo wa guy chizingani.
Atifungo sta install Windows mashine pa PC yatu bwanje. Katbanje mgambo.
Pa PC. Ni pa PC.
Mzai download ubuntu hapa.
Manje yo isatiribe matu GB buno manje ndenkani waona kunaona mara
kunkala kopala man seems
adbon
kunkala kopala man
Wafipa kuno boy.
Same nine away.
Uliva right now.
Yeah, I go away from home to get my six a place where I could go safer internet connection. Network is a problem.
You could have right.
Oi. See you on Friday.
Okay, boy.
Right. Unaposha kwa mwemba, muza excuse me.
Okay, Zamul. In fact, never I think I could be in a vac.
Right.
So voice mawe mkambatira tuza vochita.
Yeah. Mudi?
First chase kwati tapia mochimanja hapo hizi. Niko vina nguvu.
Just continue boy.
Online learning it is stressful, even to hizi zishtika.
My guy, you're not the only one. My assignments yaenda si yange na kanga hapa nyambi.
Vapaka hapa. Ilo manje
So,
na lecture series number 5 ndio.
Vimachani vao vima screen cast vao science. Sina vitambe vambili waziwa. Kai hivyo mimi tina ID hapo pa tina ID 1020 phone safe.
Yeah, 7
Wafise consider. It's too late waziwa.
Manje yenzo kamba kushta upload that won't yuanze kuika pamoja. Vinashtika video.
Okay, it's possible. Manje therefore, in fact, I should have pointed this out. Therefore, because just consider is Vajawa services are Airtel, Zamtel.
Mkam okay foot. Okay, boy, time, why is it?
Okay.